Hello and welcome back to the blue stage of DevFest Inspire. This is where we talk about mobile development. My name is Nino and I'm part of Google's developer ecosystem team. It is my pleasure to introduce you our second speaker on the tracks, Omolara. Omolara is a senior Android engineer in Neo Financial Canada. Prior to this, she was an engineering lead at Kudi Inc., where she led the efforts of her team towards building financial products. She has been doing Android for almost a decade, and she really enjoys sharing the knowledge when the time and a chance permits. So we're super glad that you have joined us today, and you're ready to share what's the fuss all about Jetpack Compose. Hi, Omolara. How are you today?
Hi, Nino. I'm very well, thank you.
Great. Well, the stage is yours.
Okay, thank you, Nino. Hi, everyone. My name is Omolara Adejuwon, and I'm a senior Android engineer at Neo Financial, where we make financial services accessible and available to Canadians. And today I'll be talking about Jetpack Compose. It's a pretty intro level to Jetpack Compose because over the past few months we've heard this phrase or these words being thrown around everywhere, and many people have wondered if this is in the future of Android development, even what Jetpack Compose is. Some people don't even know. Well, I know a lot of people have already joined the train of Jetpack Compose. And I just want to talk to us today about what the force is all about, if you should consider it, and if you would want to consider it, how you can probably get started into it. Like I said, it's pretty much intro level and it suits everybody, from you not even knowing what Jetpack Compose is and to someone who already knows what it is and is just needs the final conviction to jump on the Jetpack Compose train. So I'm really hoping that by the end of my talk, you would have had, reasonable conviction to start using Jetpack Compose in your future Android applications. All right, so let's get started. All right, so what is Jetpack Compose? You would probably want to know. I would say Jetpack Compose is just a toolkit for building native Android UIs. And I mean, over the years, almost throughout the entire life of Android development, we've been used to using the usual XML plus your Java/Kotlin to build your Android UI. Goes from building your layouts in your XML and then going back to your Java/Kotlin code to attach actions or to set one or two things before it's rendered as you would want it on in your app, right? So Jetpack Compose is just a nice way and a fancier way and a definitely better way to build this sort of native Android UIs. And you might be wondering why exactly. I mean, everybody has been used to doing it the legacy way, which is the XML way. So what exactly is Jetpack Compose trying to solve, right? If you evaluate that very well, you would know that it's not been the easiest way to build your UIs. I mean, the XML way, because in fact, over the past years, you would have seen different ways this has evolved from using view binding to data binding and different styles that developers have come are about to just make sure that this life is entirely easy. But now Jetpack Compose has just come to make this life easier for everybody. And I will just go over the things that Jetpack Compose has come to solve particularly. It's definitely less verbose than if you are using your XML, because I mean the picture I painted where you would have to declare your layout in your XML file, then go all the way to your activity or your view to perform action or to set text or to do whatever. It's sometimes strenuous, especially if you have a very complex UI to build, and the fact that you need to have extra XML files in your resources folder. Because imagine you have a very complex screen where you have lots and lots and lots of independent layouts. That means you have if you want to really separate stuff, then that means you have to have at least 1 to X number of layout files just because you want to build UI. So Jetpack Compose has reduced this verbosity into the barest minimum, and I will show examples in subsequent slides. Then another thing it has come to solve is it's more declarative and definitely more descriptive. For example, now anybody that understands Kotlin, when he or she sees a snippet of code written in Jetpack Compose, you can almost easily tell what this block of code is trying to do, or is trying to solve, or is trying to build, right? So it's just intuitive, it's declarative. For example, right from your Kotlin code, you can say this view should have 3DP padding. You can say like right from there, so you don't have to go all the way from switching from XML to your Java Kotlin code to understand exactly how actions are being performed in your code. And then the next one is easier to separate concerns. I mean, if you've been writing code, not even Android code, if you've been writing code for a while now, one of the best ways to write scalable codes or build scalable projects is making sure that your code base has what we call separation of concerns, where each module or each function or each method just handles one particular thing, right? So Jetpack Compose is just putting this further into our faces, and also like emphasize on the fact that this is a compulsory principle or concept in software engineering, right? So Jetpack Compose further allows you to express this concept by making sure that each block of code / composable just does exactly what it should do. And you stacking things on top of each other just make sure that, for example, now, if you have a UI so for example, you want to build a UI, let's say a chat UI, right? You can build just a model, a function that describes the chat box, then build another consumable function that describes the what's called now the message, and then you can stack that on top of each other, where each function just handles exactly what it should do, and then you can easily reuse these things over and over again. And it makes coupling and cohesion very, very realistic and far better than what it used to be when we were all using the legacy UI toolkit. And then another fantastic one is that it handshakes well with your existing code base. So you don't have to like ditch your entire code base just because you want to adopt Jetpack Compose. You can start right from where you are. You can start introducing Jetpack Compose little by little into your code base without having to go extra mile to without wasting business time, basically. Because I mean, realistically, no company would really allow you to stop business operations just because you want to migrate from one toolkit to the other toolkit. So yeah, you can just start from where you are in your code base without you having to ditch a lot of things. All right, so I was talking about verbosity, right? So imagine this snippet is a very familiar one to everybody that's at least written Android app before in the past. I mean, everybody uses text view. And you would be familiar with this block of code where you just declare your text view, you put your how you want your view to relate to the parent and all that, and then you set the color, you set the text, and some other things you would do in your text view or in your layout, depending on what you're trying to build. And so this is what we are used to, and this is not even considering the fact that most times you will still need to go back to your view to modify this view a little bit. Probably want to set text, or you want to change the color of the text based on some logic or whatever it is that you want to do. So this is the legacy way of doing things. And if you want to just write this in the Jetpack Compose way, then you have just this one liner that says, you know what, just present a text to me on the screen, and then put a text in it that says, welcome to DevFest Inspire. That's just it. I mean, it can go more complex than this, definitely. But if I want to interpret exactly what you have on the left side, then you would have what you have on the right side. So comparing the verbosity is less, I mean, is saner to have it this way than have it the other way. So yes, if you've like built complex applications using the current or the legacy UI toolkit, you would understand the ease of using Jetpack Compose in your future applications. So still on verbosity, the one of the ones I dread the most was recycler view, because recycler view was just complex for no reason. I mean, you would you would agree with me that to build a simple collection of items, you would have to do a lot, from adding a recycler view to your parent layout, to creating another layout for your view item, then to go back to your Java or Kotlin code to build your adapter, the all combined view, the on-create view, and all that, setting listener and all that. It's sometimes it's just complex most times, and you have to go through all of these things to just make sure that your recycler view displays or is shown exactly how you would want it to show, right? And what like is one of my sweetest parts of Java Compose. Like, I can't overemphasize how easy it is to build lists in Jetpack Compose. So let's take a look at that. Yeah. So this is all you would need to do. I mean, we are ditching all the adapters that would have to create all the click listener and all that just for this. And it's just a lazy column and then you just put how you want your view to be stacked inside the scope, and then you're good to go. And this renders just perfectly. I'm still going to like do a bit of comparison to see what you'll probably have in subsequent slides. All right, so when I say declarative, what exactly was I trying to say? So imagine this block of code that says it's called, the function is called swag, and I say when color is red, compose red swag. When color is blue, compose blue swag. And when it's none of these colors, then compose no swag at all, right? So I mean, anybody that picks up this line of code would know at a glance that, okay, this is what I'm trying to do. Basically, I'm tying what should be composed to business logic or business decisions or whatever. So imagine it's a more complex decision that we are making, right? So you can just at a glance, as your code is compiling, it's telling you. I mean, is defining and is knowing exactly what it's building. I mean, it's composing from using this switch statement now. If the color is red, don't bother to attend to blue swag or no swag. Just compose red swag, and that's it. And then if you check what red swag is doing, which is the block of code I have by the right, it just displays a random text that says do some dramatic stuff in red. I mean, it depends. This is an example, so it depends on exactly what you're trying to do with this logic and decisions. So yeah, let's go in depth further down. So what are composables? Would just say composables are just independent Kotlin functions or lambdas that are annotated with composable. I mean, the annotation composable, and that's just it, to be very honest. And then you would see that by the right hand side, you have some code snippets that just shows, like I used in the previous example, where you want to show some composables based on some business logic. You have the red swag, the blue swag, and no swag. So basically, it's just a Kotlin function, and the flex of you having to build everything you need to build in just Kotlin without you having to move back and forth between XML and your Kotlin now. That flex, it's a lot to even give you peace of mind, if I may say so. And so it's just regular Kotlin functions that can stand alone by itself, and then do some and build you some nice UI based on exactly what you want to achieve. So I'm saying now that red swag is just a composable that displays a text, and text is also a composable, but they are already internally built by the Jetpack Compose library, so you don't have to worry about all these ones. So it's just about you putting composables into each other to give you a nice experience, to give you a nice view without you having to go anywhere else but your Kotlin code. Also, a screen that you see, let's say for example you're building a chat app, like I said earlier, that screen itself has lots of composables in it, and I mean from stacking it onto each other. So a UI, I mean, one layout like that is built with a bunch of composables, and they are very, very easy to read. So look at this function I have here, where I have the work item composable. What work item is doing is just to show me an image, a text in an horizontal manner, right? So when you like run this block of code now, you're going to have a view that has just an image and a text beside it. And this is all this code is doing right here. So now, how do we then build composables? So I'm just going to take a deep dive into the possible elements we have right now. I'm not going to definitely touch all the elements because there are a lot. So I'm just going to like pick on like 3 or 4 that you would probably come across every time, almost every time in every simple application. I mean, for sure, you would come across column, right? Column is just a way to stack other elements in vertical arrangement. So you want to put things on top of each other. For example, you want to have a chat box, a text box, and each like that in vertical arrangement. So that's where you use column. And I did a demo of that on the right side, which is text, welcome to DevFest Inspire, and then a button that says say please. It just displays like that in that vertical manner. And then another one that looks like it is row, but instead of vertical manner, row just displays in horizontal manner. And I have what it will look like also on the right side, where you have welcome to DevFest Inspire, and then the button which is on the other side of it to say please. Yeah, and then we have, when I was talking about recycler view earlier, I put recycler view and lazy column side by side. So this is just what a lazy column would do, or a lazy row. But I mean, using recycler view as an example, lazy column is just a column that arranges stuff in vertical arrangement, definitely, and then can recompose when stuff leave the screen, just like you would have for recycler view. If you understand how recycler view works very well, you understand that the screen, the UI rather, disposes of views that are not visible at that moment. So it's similar to how lazy column works. So it's lazy in rendering the view that are not currently being shown. That's just like the summary of that, right? And then so you have, look at this lazy column now. It has the item, and then it has items. So item is just, it doesn't take any list, it's just there. So it just takes in, it's like you are describing the scope of the lazy column, like what should be inside the lazy column, right? So the item just takes in one composable or more composables. But for items, it takes in list of objects. So let's say you want to display your contact list. You have an array or a list of whatever it is, then you can pass that list into items. Then just tell items how to render each item. I don't know if that makes sense to you. So imagine we have list of contacts, right? So just pass that list of contacts into items, then tell items how to render each contact, right? So now a typical recycler view or a typical list view would have a header and the list of whatever it is that you want to build. I mean, if you remember how recycler view would have done it, you would have to, have different views for in your adapter and say if this view is header, display this one. If it's not, display this one, and bunch of boring stuff. But then this is just what you need to do. Describe what your header should look like in your header, and then describe what each contact item would look like in your items. And then by the right side, you have what it will look like. So I'm assuming that my header composable has just the text called the header, and then my contact view item has just the image and then the name and the phone number and all that. So it's stacked like that. And so it's similar also for lazy row if you want to have a list of stuff in a horizontal manner. Yeah, I really hope that makes sense. Okay, while I wrap up what happens here, you are going to see a lot of modifiers, and modifiers are just way for you to modify, as the name already suggests, to modify what an element or what a composable looks like, right? For example, now you want to modify what the text looks like. You want to change the text color. You want to add some padding, or you want to make it clickable. You want to put a background or whatever. Modifier is where you're going to have everything done. And there are lots of functions already that modifier that you can apply on modifier to just basically modify stuff. So there are lots of functions already for you to use if you ever need to change whatever it is that you want to change, just to satisfy what your UI should look like. All right, so state management is one thing that is quite it's a compulsory topic in Jetpack Compose, because it's like the base of everything Jetpack Compose, right? And then sometimes it can be really, really, really challenging for people to understand what state management is all about, because it's a very, very broad, but not that difficult anyway. But let me try and do justice to that. So what are states? So states is like anything that your composable needs to render, right? It can be any object whatsoever. And like I said, the state holds the data used in the composition. So you have a list view, or you have a view that displays an image and then a text. So that text being displayed, so like I used in my previous example, I said, welcome to DevFest Inspire, right? So welcome to DevFest Inspire is like a state already. So because, I mean, your composable needs that value to render whatever it is that needs to be rendered, and it can change. States can change, and when it changes, it recomposes your view. It recomposes the composable, like it redraws the composable back to the screen and all that. That's just that in layman term, right? So state holds the data using composition. So whatever it is that you are trying to use to render the composition is called states. It can be anything at all, from color to variables to whatever it is that to UI states, in fact, to anything at all. Then Compose automatically observes changes to the state. So when the state changes, you have the screen redraws, the composable recomposes, right? And then so it's seen for you to just watch that, so that it won't keep drawing every time. So you don't need redraws when the state of that composable changes. And then composables do not recompose when the state stays the same, like I said in my previous point. So it only redraws when there's a change in the state. So imagine this block of code I have here that says, it's just when you click on the button, right? It says the text displays number of times you pressed the button. So imagine you click the button 5 times, then the text will say button clicked 5 times. So the content of text remains the same, even though you are changing counts, right? You are changing counts, but because you've not told your text to observe the variable called count, even though you are changing counts a couple of times, the count is actually increasing, but your text view, in this case now, your text is not aware that the count has changed or is changing. So the text will just remain the same, button clicked 0 times, right? So this is basically because the button clicked X number of times is the state for this composable. Well, can be the state for this composable, because anything can be state anyway. So now the content of this view remains the same, because it's the text, the composable does not know to observe the variable count. Remember, so how do we then solve this, right? So we are going to introduce something called remember. So count now becomes a mutable state. So basically you are telling the composable to watch this variable, right? To watch this variable, that anytime it changes, every composable that observes it would also need to, redraw and recompose rather, and display the latest value to the view, right? So we have that, and then just saying now we are declaring counts to say mutable states initial value, which is 0, and then when you click on the button, right, you just increment the value of the count. So what remember is doing here is just to remember that value, just as that, remember this value over time, right? And this is not, if you look at it also very well, this is not like a very, very nice approach, because imagine that you want to reuse the state composable. You want to use like this function now, you want to reuse it somewhere else. That means the count value will always be inside the variable. I mean the function. So imagine you want to use this state somewhere else, right? Is that you have to copy your code and put it somewhere else, like create another function entirely that does pretty much the same thing and all that. So how about also imagine that you want to test this composable. It's very, 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 very hard to test because the variables are living right inside of the composable. So how about to find a way to just bring it out? So this state is called stateful composable. And stateful composable by at large is not like the best way of building your composable. You want to make your composable really, really lean at best. But then this function I have by the right already knows so much about the variable called count. Like for example, it's responsible for setting the value here. If you look at this line, when you click on the button, the function is responsible for setting the value, and it's also responsible for knowing the value. And it's not like the best approach. So then how do we then solve this? Then we have something we call state hoisting. So it's just basically turning a stateful composable into stateless composable, right? And it's the summary of state hoisting is just that make sure that your state now, which is in this case our count, the variable count is our state. So make sure that your state is external. Basically, you tell your composable to get the state from outside, and then you also tell your composable to tell the external that this value is about to change and tell it what to update it to, basically. So this is what we have now. So we want to change our previous function, which was stateful, to something stateless. So like I said, we are going to introduce new parameters, which is the count that we want to display on the text view, and then a lambda function, a lambda that just tells your external that this value is about to change. What should we do? How do we change it? How do we save it? What do we do with it, right? So basically, we take this out and introduce this, and then this is what the full function looks like, right? So I'm using stateflow. It can be anything at all. You can use live data, you can use RX, Java, whatever it is that's comfortable to you. And the good thing is that Jetpack Compose has a way of converting these standard libraries into the mutable states that composable needs, right? So I'm using stateflow, Kotlin flow rather. And then so I pass in my count, which is from an external source, whatever it is that needs to call the stateless composable. I pass in my state, and then I get that state as mutable state that composable understands now. And then I just, I set the text to say button clicked, then the state the value times, and then I also pass in a lambda to say this is what is about to happen to this value. So it's like this function is accepting something and also telling the external to say this is about to change to this value, do something about it. So that's basically it. So anytime this count changes now, our text is aware, and then it recomposes, and then it displays the updated number. So that, and so let's say we want to call stateless from somewhere outside, let's say from another composable or whatever. We just need to call stateless and then pass in the count. So I'm assuming the count is coming from view model. It can come from anywhere. It doesn't have to be view model, but based on your business decisions or what your data layer looks like, right? But so I'm assuming the count comes from view model, and also you also let view model know how you want to change the value. It can be anything. Let's say you want to store the value in your database, or you want to, do whatever it is. You can do whatever it is to you, because in fact, other parts of the app can also depend on the count. So imagine you had left your count in a stateful situation like we had in our initial example, right? It would have been very, very, very difficult for your other parts of your app to know what the value count holds, right? So yes, this is what calling it would look like, just passing the count and also passing a lambda that lets you know that this is about to change. So okay, so let's talk about testing.
I'm very sorry, but I fear we've approached already the end of this talk.
Oh,
But
okay.
Our amazing colleague Nino, who I magically summoned to the stage, can help everybody else find you on Spatial Chat. I understand that you're going to be available on Spatial Chat, so that you can also
Yes,
help
I will.
answer other talks. If people have questions around what you're doing and the way that you recommend to handle XML-based layouts versus Compose and so on. So sorry to cut you
Okay,
off, but
that's
sadly the
fine.
next session is
That's
starting
fine.
very shortly. Thanks so
All
much
right,
again
that's
for
fine.
taking the time.
All right. Bye bye. Thank you for having me.